So when we differentiate the natural log function, we get the answer 1 over x. Now what we want to do is to explore variations. So for instance, if we have the natural log of cos of x, so what we do is, in the same way that we had natural log of x giving us 1 over x, these parts correspond. So we have 1 over cos of x. But what we must do is remember to multiply by the derivative of the bracket. Now in this case, the derivative of x is simply 1, so the multiplying 1 is not shown. When we differentiate cos x, we get minus sine of x. So minus sine x over cos x gives us minus tan of x. Second example, y equals natural log of 2x minus 3 squared. Now this power here is a problem. What we're going to do is to take that power down to the front. So what we have then is 2 times the natural log of 2x minus 3. This 2 will not feature in the differentiation. So dy by dx then, we'll put down the 2 and forget about it. Natural log of 2x minus 3, that will become 1 over 2x minus 3. Multiplied by the derivative of 2x minus 3, which is 2. So we end up with 4 over 2x minus 3. So example 3, what we have here is a product. We've got e to the 2x times natural log of sec x. I'm going to apply the product rule. Why don't I write down the different parts? So u is e to the 2x. Now when we differentiate e to the 2x, we get 2 lots of e to the 2x. So we multiply the function by the derivative of the power. Natural log of sec x. So when we differentiate this, we're going to have 1 over sec x times the derivative of sec x, which is sec x tan x. And we'll simplify that. These parts will cancel, so we just have tan x. dy by dx, so we differentiate the first and leave the second, so it's 2e to the 2x times natural log of sec x plus leave the first and differentiate the second. Now we have e to the 2x common to both terms, so we'll take that out as a common factor. And that leaves us with 2 times natural log of sec x plus tan x. I suppose what we could do, we could also take this 2 up. I don't know whether that would be considered neater. Example 4, we have a quotient here, so we're going to apply the quotient rule, although we may not have to. First thing to do is to consider the top line. The very first rule of logarithms is that logs of the same base, when we add them, can be changed. So I can write that top line as 3x times 2x, that's 6x squared, over e to the minus x, But I can also move this e to the minus x. If the term has a negative power on the bottom line, we could move it up onto the top line, and that will give us e to the x natural log of 6x squared. So if we differentiate this, differentiate the first, well, if we differentiate e to the x, we just get e to the x. Leave the second, leave the first, and differentiate the second. So we'll have 1 over 6x squared times the derivative of 6x squared, which is 12x. E to the x then, natural log of 6x squared, and we have different pieces cancelling out. So that gives me 2e to the x over x. And I think what we could do is maybe have e to the x as a common factor. And I'm going to write 2 over x as 2x to the power of minus 1.